Hello, good morning. Today we talk about the properties of arithmetic mean. So what is the properties of arithmetic mean? Properties of arithmetic mean. First of all, point number 1, sum of deviation of data from arithmetic mean is always 0. So this is the features of arithmetic mean. But the question asks, justify the arithmetic mean is sum of deviation of arithmetic mean is always 0. So we can take the example. If the question asks, justify that sum of deviation of data from AM arithmetic mean is always 0. So for this type of question, we can justify it with an example. Answer, solution. Suppose we have data set, thus 20 and 30, 10, 20 and 30. So first we calculate the mean. What is the mean? The mean is equal to 10, 20, 30 by 3. It means that 60 by 3, 20 mean. So now we calculate the deviation, sum of deviation. Deviation means difference, deviation of data from arithmetic mean. So we first of all we cite the data x, 10, 20 and 30. And what is the deviation? What is the deviation? Deviation means sum of deviation of data from arithmetic, x minus x mean. So 10 minus mean is 20 minus 10, 20 minus 20, 0, 30 minus 20 plus 10. So sum of deviation x minus x mean is equal to 0. Minus 10 plus 10, 0. So this is the justification answer. So it means that we can write it as sum of x minus x mean is 0. Sum of deviation of data from arithmetic mean is always 0. Features number 2, sum of square of deviation of data from arithmetic mean is minimum. In respect of other assumed mean, assumed values. So it means that x minus x bar square is always smaller than x minus a square. So to justify these properties of the arithmetic mean, we have to take the example. For example, the question asks to justify that the sum of squares of deviation of data from arithmetic mean always minimum. So for the justification, we should have to take the example. Suppose we have data set 10, 20 and 30. So first of all, you calculate the mean. What is the mean of this data set? X mean is equal to 10, 20 and 30 by 3. 60 by 3, it means that 20. So now the deviation. First, the sum of squares of before the square calculation, we have to calculate the deviation. So actual values of the data, x is equal to 10, 20 and 30. So now what is the deviation? X minus x mean. So it means that mean is the 20, 20 minus 10, 20 minus 20 minus 10, and 20 minus 20 0, and 30 minus 20 plus 10. So now the sum of squares is, this is the deviation, and squares of deviation, it means that x minus x mean square. So case 1, so 10 square 100, 0 square 0, and again 10 square 100. So what is the sum of squares of the deviation? 200. So case number 2, to verify that the sum of squares of deviation from the mean is minimum from other assumed mean. So suppose the assumed mean is 10. Then so we should have to calculate again the deviation 10, 20 and 30. So what is the deviation? X minus a. A is the assumed mean, which is we take as a 10, 10 minus 10, 0, 20 minus 10, 10, and 30 minus 10, 20. So now, so we have to calculate squares of the deviation. So 0 square, 0, 10 square, 100, and 20 square, 400. So now, so we have to call sum x minus a square is equal to 500. So what you see that? So it is the arithmetic mean, it's the assumed mean 10. So here is also deviation, squares of deviation only 200. Here is the squares of deviation 500. So you can justify that the sum of squares of the deviation is always minimum from the arithmetic mean. So you can also take the examples, case number 3. Suppose you have assumed mean is equal to 30. So then we have to calculate the deviation x minus a, and x minus a square. So here is thus 20, 10, 20 and 30. So what is the assumed mean? 30. So 10 minus 10 minus 30 minus 20, 20 minus 30 minus 10, and 30 minus 30, 0. So we have to squares 400 minus 20 square 400 minus 10 square 100 and 0 square always 0. So what is the x minus a square? 500. So what is that? So case number 1 is a deviation, squares of the deviation of the data from arithmetic mean. And the case number 2, squares of deviation of the data is from assumed mean 10 and assumed mean 30. So what do you see that? The mean, squares of deviation of the mean from arithmetic mean is 200, in respect of case number 2, 500, and in case number 3, 500. So what is calculated that? So based on above statement, we can call as sum of square of deviation is always minimum from arithmetic mean. Yeah. So if the question asks, you can write as like that. So features number third. What is the features number third? What is the properties of arithmetic mean? If the data set is increased or added by constant values, then arithmetic mean also increased by constant values. So what it means that mean depends upon addition values. Mean depends upon addition values. If the data set is increased or added by constant values, new mean, arithmetic mean also increased by constant value. It means that you can write that new mean is equal to old mean plus constant values. This is the conclusion. So, what is the justification? What is the proof? So, we can prove that. So, if the question asks, justify that every set of data is increased by constant values, the new mean is equal to old mean plus constant values. So, what is the features? What is the, for justification, we should have to take the example. Suppose we have a data set. Very simple, 10, 20, and 30. This is our data set. So, first number x, 10, 20, and 30. So, we can calculate the summation x, so 60. And we can calculate the mean. Mean is equal to 60 by 1, 2, 3, 3, so 20. So, what is the old mean? Of a mean of the original data, suppose we assume the constant values. So So we assume the constant value 5. Then every data is increased by constant value 5. The new x values, new data set is equal to 10 plus 5, 15, 20 plus 5, 25, and 30 plus 5, 35. So now we have to calculate summation x and 40, 60, 75. So 75. So what is the mean of the new data? So 75 by 3. So what is it? When we divide, it becomes 25. So we can see here old mean is equal to 20 and new mean is equal to 25. And what is the constant values? Constant value we add is 5. So we have to calculate what is the difference of old mean versus new mean. The difference values is equal to 25 minus 20, 5. So you have a constant value of 5 and difference of the two mean is 5. So it can be justified that new mean is equal to old mean plus constant value. So new mean is 25, old mean 20, and what is the constant values? 20. So we can directly write right hand barabar left hand. So here we justify that if your data is increased by constant values, new mean is also increased by new mean arithmetic mean is also increased by constant values. It means that new mean is equal to old mean plus constant values. Thank you very much. So now the feature number 4. What is the properties of 4? If each data, each values of the data is decreased by or subtracted by constant value, so then arithmetic mean also subtracted by constant values. So what is the meaning of that? It means that new mean is always equal to old mean minus constant values. So this is our conclusion. But you can justify this statement also. If a person asks to justify that every set of data is increased, not increased, decreased by or subtracted by constant values, new mean is equal to old mean minus constant values. So this is your question, and we need a justification, a proof. So suppose we have a data set 10, 20 and 30. And x is equal to 10, 20, 30, 60, summation x, and mean we calculate 60 by 3, 20. So mean of the original data 20. Suppose the constant value we subtract is also taken as a 5. So now the new data, we represent here xn. So 10 minus 5, 20 minus 5, 15, and 13 minus 5. We can write 25. Then summation x, so 20, 45. So what is the new mean? 45 by 3. So we calculate here 15. So new data and their new mean, old data and their old mean. So now, what is your old mean? It's called 20 and new mean 15 and constant value subtracted 5. And what is the difference? So here we calculate the difference. 20 minus 15, which means that constant value is 5. So what is our new mean? Old mean minus constant values. So we put here, and new mean is equal to 15. We calculate here 15, and old mean you calculate here 20, and what is your constant value? 5. So what we can draw 15 to the is equal to right hand is equal to barabar left hand.